Hey YouTube, I hope all is well. I'm making this video on memory address and what it means and how to use it. Now, I'm going to use a few of these links that I have open here. Some are from the official documentation of JavaScript, and it's going to help me explain some of the concepts I'm going to go over in this video. And I'm going to be using JavaScript, although this concept should work for most, if not all, programming languages. So, first, we have to understand what a primitive is and what an object is. So, in programming, a primitive basically is just it's just a raw value. It's not an object that doesn't really have behavior. It's just raw state, right? Now, to better illustrate this, I'm going to come into the console. I'm going to say 1 is equal to 1, right? And that's true, because 1 is equal to 1. And there's nothing we can do to change this logic. 1 will always be 1, right? Now in JavaScript, some of the other primitives are strings, numbers, big integer, boolean, null, undefined, and symbol, right? So if I were to test strings out, so if I say a is equal to a, that's true. A will always be A. The same thing with booleans. If I say false is equal to false, that's true, right? So those are primitives. Now, besides primitives, we have something called an object, right? So in computer science, an object can be a variable, data structure, function, or method, and as such is a value in memory, referenced by an identifier, right? So basically an object is some sort of concept, and basically it's a container for raw data. So let's say I have a variable. I'm going to say a is equal to 1, right? Now 1 isn't an object. So when we assign 1 to A and we call it, we get A, right? Now let's say I create another variable, B, set that equal to A, right? Now what's happening here is when we're assigning a value to a new variable B, it sees that this is not a primitive, right? It's not an object, it's just an identifier. So I have to figure out what the value of this identifier is. It sees that it's a primitive, right? Now, because primitive isn't really an object, what happens is that it gets copied to this variable, right? So if I call B, it's 1. Now let's say I reassign A to a new value, let's say 2, right? So A is 2, but if I call B, it's still 1, right? That's because at the time B was being assigned, the value that was being assigned was a primitive, so it got copied over. Now, an object, like this description said, is a value in memory. So let's say I create an object, A equal to an object literal, right? Now if I call A, we have a basic object. It has no properties, no methods. It's empty. Now let's say I create a new object and another variable. If I call B, we see that this is also an empty object. No properties, no methods. So looking at A and B, we can see that by value, they're pretty much identical. They both don't have any properties. They both are the same data type. They're both objects. So in theory, from like, at a broad high level, these should be equal in value. So if I said A is equal to B, that's false. Now why is that? Well, again, let's take a look at what's happening. When we're creating a new object, we're creating a new instance, right? So an object is an instance of a class. So when we're creating a new instance of an object, it's creating a new memory allocation in order to reference that particular value in memory, right? And we're doing that 2 times. So these are 2 different objects in memory. A and B have 2 different memory addresses. And because they have 2 different memory addresses, the comparison is evaluating them as false. These 2 are not equal because they have 2 different memory addresses. And these are not primitives, right? Now, because A and B are both technically memory addresses to these objects, if we assign a new variable, let's say C, and we say C is equal to A, what's happening here is that when we're assigning a value to C, it's finding this identifier, it sees A, and it sees that it's pretty much a memory address to an object. So that memory address gets copied to C, right? So because A and C now both have the same memory address, if we try to evaluate them or do a comparison, A equal to C, that's true. A and C have the same memory address to this particular value, this particular object in memory. So to further illustrate that, if I say A.age is equal to 1, and we call A, we see that age property on this object. Now, I set this on the A variable. If I were to call C, we also see that age property there. Okay, we modify the A property, but we see it on C because C has the same memory address as A. So whenever A gets updated, anything else that has a copy of that memory address will still see that change. Same thing, if I were to say C.ID is equal to, let's say 0, right? I call C, I see that new ID property. If I call A, we also see the ID property. So you can think of objects pretty much as a reference type, meaning whenever you assign a value to a new variable, say var ID is equal to C, if that's an object, then it's going to reference that, pretty much copy the memory address. If it's not a primitive, I'm sorry, if it's not an object and it's a primitive, then the value is going to be copied, not referenced, right? So again, we have D, we set it equal to C. C is just a memory address that was copied from A, so technically D should be equal to A, which is true. A, C, and D all have the same memory address to this value in memory, that particular object, right? So hopefully this explanation helped. If you have any questions, just leave a comment in the section below. Please subscribe, ring the bell icon to get updates on any video I put out. Thanks for watching. I hope you have a nice day, and I'll see you guys later.